All right, Python students, a couple more tips before you're really ready to tackle the project challenges in this unit. The first thing I want to show you is a tip for comparing strings. And to do so, let's create a couple of them. I'm going to make a word here that's Tuesday, and another word 2 equals Tuesday with a capital T. And I want to print out if word equals word 2. And we'll see what it tells us when I print this out. And it says false. The words are both Tuesday. Let's zoom in a little bit more to make sure that's really obvious. Maybe I should have done that from the start. The words are the same, but because they have different capitalization, technically they're not the same. We're not thinking about the actual meaning of the words. We're thinking about the literal characters that make the word up. So we'll see here, if I make this a lowercase t, this would now be true. So how do we deal with this to be able to manage cases where the words are the same? We want these to be considered the same, despite them not having the same capitalization. Now, there might be some cases where you want the capitalization to matter, and there might be other ones where you don't. And if you don't, here's the simple strategy. I can just put beside the string the method lower, which is going to not change the string, but allow it to be compared in a lowercase form. Now when I run this, it says true, despite there still being a capitalization difference. And just to make this really clear, let's just change a bunch of the different characters. And this is still true, despite it being very clearly differently cased. So this dot lower allows us to make this comparison with what we call case agnostic. So we're not going to care about the cases of things. Really relevant in some components of the work that you're doing. The second tip I want to give you is one thing about brute force decoding. And I don't really actually want to write any code here probably, but I want to talk about this allwords.txt file that you have that you'll be using potentially in your brute force decoding. Actually, let's just type down a couple notes here. What is it that we need to do when we're brute force decoding? Well, first we need to have our program automatically attempt to decode the file. So you're going to get some result from it, which chances are is not correct. It's unlikely you'll get it the first try. How are you going to attempt? Maybe you have a preset list of things you're going to attempt. Maybe you randomize it. It's up to you how you want to build that algorithm. But once you do, you need to have your algorithm and your whatever code is running right now. Take a guess or take a look at the contents of the decoded file and decide. I'll put the next line here, whether or not it's a good attempt. How are you going to do this? How are you going to get your program to be able to make a decision about whether or not it's a good attempt? Well, here's one tip for you. If I have like some encoded information, I don't know, maybe it looks like this, encoded in different ways, and you decode it and it ends up looking like this, then you know with a human eye that is not a reasonable outcome. But what if it says like to be or not to be? That is the question. What if that's like the output? Well, this is kind of too long. That is to. So what if that is the output? Well, to your human eye, really clearly and obviously, this is decoded because it has English words in it. So, but what if you were able to write an algorithm that automatically examined the contents of a guess and then use something like a delimiter to pick apart individual words or individual components of it, and then check with some reference source as to whether or not there's actually legitimate English words present in it. For example, something like your allwords text file, which I provided you for a very distinct reason. Hint, 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 hint. You have to be careful of false flags. I already noticed here the word huh appears in this random thing. O could be flagged as a real word potentially. As appears here. So here's as again. So it's possible you'll have false flags appearing here. And so you'll need to create some logic to be able to kind of have some sense of confidence level. If you have kind of individual pieces of things that are kind of flagging as maybe real words, but a lot of the content isn't, maybe that means it's a bad guess. But if there's enough things that individually flag as being a good, solid English word, then there might be a confidence threshold that allows you to confirm, yes, indeed, I'm happy to confirm that this, well, the program will say to you, I think this is the best guess. So if we had a few more things in here that were printed out, maybe some different looking characters here, you would hope that your algorithm, when it examined these 5, or I guess these 4 attempts would choose this one as the one that it prioritizes what it thought would be the right decoded version. And for the highest level score in this section, I want to see that your program in an automated way can look through an encoded file that's encoded with a Caesarean cipher in the way that we talked about in the last lesson, but actually make an intelligent guess as to what the actual decoded message will be. And so think about this idea of examining individual delimited parts, these tokens that we have inside of it, and comparing it with some reference that has a master list of things that are good English actual words. And I think that's more than enough hints. I'm going to stop talking before I give away too much of the algorithm. Good luck with it. Let me know if you have any questions.